I mamy tą prezentację? Bo nie wiem. Oh yes, we have now. My name is Konrad Maj. I'm the head of the Humantech Center at SWPS University, and I have a great honor and pleasure to open this meeting. Today, we are going to talk about human senses and technology. Our keynote speakers are distinguished guests, both actually living in California. Professor David Eagleman from Stanford University, award-winning neuroscientist and the writer and presenter of The Brain, a very famous television series in Poland as well. And Professor Piotr Winkelmann from the University of California, San Diego, and from our university, one of the most acclaimed Polish scientists researching relation between social cognition, emotion, embodiment, and consciousness. So they will tell us how technology is being used to improve the sensory experience of people who in some way have been deprived of the joy. And after those two keynote lectures, we will also have a discussion panel with great guests who will be later introduced broadly by the panel moderator, Professor Filiciak. But let me list it. Our panelist, Monica Gori from Italian Institute of Technology. We will see on the screen also. We need to wait, but Piotr, can you change slides during my presentation? So Monica Gori, Italian Institute of Technology, Professor Wodzisław Duch, Nikolaus Copernicus University, and Przemysław Kuśmierek, Migam Company. And brief information about our Humantech Meetings project. So the project is co-financed by the Polish Minister of Science and Higher Education. This is a series of meetings, not only one separate meeting, meetings gathering academics and professionals from the technology sector, but there is also a kind of combination of the world of science, world of business, a kind of blend of the humanities and technology, and kind of clash of the Polish and foreign perspectives and experiences. We have organized 30 meetings so far. We have also excellent partners whom I would like to thank for their support. On the screen, you see our partners. Main partners is PFR Foundation, but also very helpful partners like Poland Innovative, Polish IT Society, Mazovia Division, National Information Processing Institute, National Research Institute, Zrobotyzowany.pl. This is internet portal. So now I would like to introduce our first guest, David Eagleman. Neuroscientist at Stanford University, Guggenheim Fellow, presenter of The Brain, as I said before, an Emmy-nominated television series on PBS and BBC. Dr. Eagleman areas of research include sensory substitution, time perception, vision, and synesthesia. He also directed the Center of Science and Law. Eagleman is author of many books, including bestsellers like Life Wired, The Runaway Species, The Brain, Incognito, and Wednesday is Indigo Blue. One of the book, Sum, has been translated into 32 languages, turned into 2 operas, and named a best book of the year by Bears and Nowe. Dr. Eagleman writes for many main newspapers in United States and appears regularly on radio and television. And I guess today he will tell us maybe more about his company, Nowe Sensory, and its products, of course. And one piece of information before I ask David for his presentation. We have several books by Professor Igeman. For those who ask interesting question in chat or verbally, so put your questions into chat. I think David and of course other guests will answer those questions during discussion panel. But if we will have space for answering, of course, between lectures, we can also do it. So there, David, welcome to the Human Tech Meetings Forum. Our, let's say, virtual floor is yours.
Great, thank you so much. It's lovely to be here. If you guys could unshare that screen, then I can share my screen.
Poprosimy o właśnie.
Great, thank you. Yeah, so yeah, it's wonderful to be here. My father's family is from Poland. That's where my family lived for many generations, and I've been to Poland, and so it's nice to be back there, although virtually this time. So here's what I want to talk with you about today is my work on understanding senses and how we can create new ones. And so, my fascination has been how brains perceive reality. And the strange part of this has always been to me that we're not seeing most of what is going on around us. So for example, we are built out of very small material, and we are embedded in a very large cosmos. And we're not particularly good at perceiving reality at either of those scales, because we have evolved to deal with reality at a very thin slice in between. But even here, we're not seeing most of the action that is going on. So, for example, take the colors of our world. These are light waves that bounce off of objects and hit our these specialized receptors in the back of our eyes, but we're not seeing all the waves out there. What we're seeing is less than a 10 trillionth of what is out there. So you have radio waves and microwaves and X-rays and gamma rays. These are passing through your body right now, and you're completely unaware of it because your biology doesn't come with the right receptors to detect that. So there are thousands of cell phone conversations passing through you right now, and you're completely blind to it. Now, it's not that these things are inherently unseeable. Snakes include some infrared in their reality, and honeybees include ultraviolet in their view of the world. And of course, we build machines to pick up on radio waves or X-rays, but you can't see any of these by yourself, at least not yet, because you don't have the proper sensors for that. And what this means is that our experience of reality is actually constrained by our biology. And that goes against the common sense notion that our eyes and our ears and our fingertips are just picking up the objective reality that is out there. Instead, our brains are sampling just a little bit of the world. Now, across the animal kingdom, different animals pick up on different parts of reality. So, for example, in the blind and deaf world of the tick, the important signals are temperature and body odor. For the black ghost knifefish, its sensory world is made up of electrical fields that it picks up on. For the blind echolocating bat, its reality is constructed out of air compression waves that come back to it when it chirps. So that's the slice of their ecosystem that they pick up on. And we have a word for this in science. It's called the Umwelt, which is the German word for the surrounding world. And presumably every animal assumes that its Umwelt is the entire objective reality out there. Because why would you ever stop to imagine that there's something beyond what you can sense? Instead, we all accept reality as it's presented to us. So let's do a consciousness raiser here. So imagine that you are a bloodhound dog. Your whole world is about smell. So you have a long nose that has 200 million scent receptors in it, and you have wet nostrils that attract and trap scent molecules. And your nostrils even have slits so you can take big nosefuls of air. Everything is about smell for you. So one day you stop in your tracks with a revelation. You look at your human owner and you think, what is it like to have the pitiful little nose of a human? What is it like to take a small little nose full of air and not know that there's a cat 100 meters away, or that your neighbor was on this very spot 6 hours ago? So because we're humans, we've never experienced that world of smell, so we don't miss it because we are settled into our Umwelt. But the question is, do we have to be stuck there? So as a neuroscientist, I'm interested in the way that technology might expand our Umwelt and how that is going to change the experience of being human. So many of you probably know that there are hundreds of thousands of people walking around with artificial hearing and artificial vision. And the way this works is you take, for example, a digital microphone and you put a strip of electrodes into the inner ear, and people can come to hear that way. Or you take a digital camera and you plug a grid of electrodes into the back of the eye, and people can come to see this way. Now, as recently as about 25 years ago, there were many scientists who thought these technologies were never going to work. And it's because these technologies speak the language of zeros and ones, like Silicon Valley. And that's not exactly the same dialect as our natural biological sense organs. But the fact is, it works. The brain figures out how to use the signals just fine. And so the question is, how do we understand that? Well, here's the secret. Your brain is not directly hearing or seeing any of this. Your brain is locked in silence and darkness inside your skull, and all it ever sees are electrochemical signals that come in along different data cables, and that's all it has to work with and nothing more. Now, amazingly, the brain is really good at taking in these signals and understanding patterns and assigning meaning to these patterns. So it takes this inner cosmos and it puts together a story of your subjective world. But the point I want to make is that your brain doesn't know and it doesn't care where it gets the data from. Whatever information comes in, your brain just figures out what to do with it. And this is a very efficient kind of machine. It's essentially a general purpose computing device. It just takes in everything and it figures out what it's going to do with it. And that, I think, frees up Mother Nature to tinker around with different sorts of input channels. So I call this the pH model of evolution. And I don't want to get too technical here, but pH stands for potato head. And I use this to emphasize that all these sensors that we know and love, like our eyes and our ears and our fingertips and our nose, these are just plug and play devices. You stick them in and you're good to go. The brain figures out what to do with the data that comes in. And when you look across the animal kingdom, you find lots of peripheral devices. So snakes have heat pits with which they detect infrared, and the ghost knifefish has electroreceptors along its body. And the star-nosed mole has this nose with 22 fingers on it. And that's how it feels around and constructs a three-dimensional model of its tunnels. And many birds and cows and insects have specializations to orient to the magnetic field of the planet. So what this means is that nature doesn't have to continually redesign the brain. With the principles of brain operation established, all nature has to worry about is designing new peripheral devices. So the lesson that comes up here is that there's nothing really special or fundamental about the biology that we come to the table with. It's just what we've inherited from a complex road of evolution, but it's not what we have to stick with. And I think our best proof of principle for that comes from what's called sensory substitution. Comes from sensory substitution. And that refers to feeding information into the brain via unusual sensory channels, and the brain just figures out what it's going to do with it. Now, that might sound speculative, but one of the first papers demonstrating this was published in the journal Nature in 1969. A scientist named Paul Bocchi-Rita put blind people in a modified dental chair, and he set up a video feed, and he would put something in front of the camera, and then you would feel that poked into your back with a grid of solenoids. And so if you put a coffee cup in front of the camera, you feel that in your back. And amazingly, blind people got pretty good at being able to determine what was in front of the camera just by feeling it in their back. And by the way, this is work that started, I talk about this in my book, Live Wired, my new book. This is work that started in Poland in the late 1800s. And so it was a very crude sort of technique with a single photodiode on a helmet that would get turned into noise. But it started in Poland. And then also in 1969, the same year that Bocchi-Rita published this, there was another group in Poland that did something similar. So just a historical side note there. So there are many versions of this. So just as an example, the sonic glasses take a video feed right in front of you and turn that into a sound landscape. So for a blind person, they hear sounds that tell them what's going on in the world in front of them. And it sounds, at first you can't understand what it means, but after some time, people start getting really good at understanding what is in front of them just based on what they're hearing. And a colleague of mine, Peter Meyer in Europe, has an app now called Voice, VOICE, that does this, and you can get this on your Android phone. And it doesn't have to be through the ears. You can put the information anywhere. So a group in Japan put video information onto the forehead for a person who's blind. And one of the most well-studied devices is on the tongue. So the camera for a blind person detects what's in front of it, and you feel that on your tongue with it's called an electrotactile grid. And blind people can get so good at using this that they can do things like throw a ball into a basket or navigate complex obstacle courses. They can come to see through their tongue. Now, that sounds really crazy, right? But remember, all vision ever is electrochemical signals in your brain. And your brain doesn't know where the signals come from. It just figures out what to do with them. So in my laboratory, we set out to solve sensory substitution for people who are deaf, people who can't hear. And we wanted to make it so that the sound from the world gets converted in some way so that a deaf person can understand what is being said. So we built a vest, and the vest has little vibratory motors all over it. Think of the buzzer in your cell phone. Bzz. So we have 32 of those in the vest. And they map sound from low to high frequency. So I'll give you a sense of what this looks like. Oh, shoot, the sound isn't on. I'm sorry. Well, what I'm doing is I'm talking here in this, and actually, I might be able. It's not. I'm not going to be able to do it in time. Fine. What I'm doing is I'm speaking, and as I'm speaking, the sound is getting translated onto the vest so that I can feel what's going on. So here's another example, just so you can see it. The woman is saying the word sound on the left, and she's saying the word touch on the right. And you can see how this is getting mapped onto the motors. And so she can feel that, as there's noise in the world. So I'll just mention, this was our very first participant ever. He was born profoundly deaf, which means that there's a part of his Umwelt that is unavailable to him. So we had him train with the vest for 4 days, 2 hours a day. And here he is on his 5th day. Let me just see if there's a way that I can, give me 1 second to see if I can get the audio working here. This might work. Okay. So this is my graduate student on the right. This is Jonathan on the left. And my graduate student will say a word. Let's see if this works. Okay, doesn't work. I'm sorry. So my graduate student says the word you, and Jonathan feels the pattern of vibrations on his vest and he writes it on the board. So Scott now says the word where, and Jonathan is able to translate this complicated pattern of vibrations into an understanding of what's being said. Now Scott says the word touch, and Jonathan is able to translate this based on what he's feeling. Now, he's not doing this consciously because the patterns are, very complicated, but his brain is unlocking the pattern. Exactly like when you hear, you're not thinking, oh, Eagleman is saying something that's low frequency and high frequency and middle. You just hear what I'm saying. It's the same thing that's happening with Jonathan here. And by the way, if you've ever seen somebody, let's say a blind person who's reading Braille, the little bumps on the page, they don't think, oh, okay, let's see, there's a bump there and a bump there. Instead, they're just reading the book and they're crying or they're laughing because the meaning comes directly off the page without conscious intervention. And that's what Jonathan is experiencing here. So we recently had this gentleman over to our laboratory, and he's deaf, but the reason that he was there it wasn't because of him, it was because of his daughter, who was born both deaf and blind. And so we made a little miniature vest for her, and the phone is picking up on different sounds. And so she's getting to tap into the world around her and get the sense for the very first time. And so here her grandmother is taking her around and, talking to her and touching her against things. And it's hard to see on the right, but the bed is actually going down and up, and the grandmother saying down, 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 up, 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 things like that. And what we've done in the meantime is we've made this into a chest strap for children who are deaf. And so children who are deaf can wear this chest strap. But what we've done in the recent years is we have made this into a wristband, and the wristband has vibratory motors on it. And that allows this research to be much simpler because we've shrunk this down to the size of a Fitbit now. And so now we are on wrists all over the world. So here was our very first participant. This was back when it was a larger thing, but he's talking about what this means to him to be able to pick up on sounds and get those to his brain when he didn't have access to that before. So, he's saying when his wife calls him, he can feel her name, he can hear her call his name, and so on. So as I said, we're on wrists all over the place. I'll skip this, but I'll mention we put together a word cloud based on, users coming to us and telling us about sounds that they picked up on that they didn't even know existed or were surprised to hear, surprised that they were able to pick up on. And, the reason this matters is because we can build this technology very inexpensively. I'm showing the vest here, but really what we're concentrating on now is the wristband, which is just several $100s. And this is a real game changer because the only other opportunity for people who are deaf is a cochlear implant, which is about $100,000 in the United States. That's the technology plus the surgery. And so ours is much, much less expensive. And so one of the things that I'm working on now is getting this into deaf schools all over the world as a charitable thing. So I'll just mention several other things that we're doing with it. One of the things we've recently been working on is it turns out this is really useful for for ringing in the ears, known as tinnitus. So what we do is we have people listen to tones and they feel vibrations on the wrist at the same time. And it turns out that is something that is scientifically shown to reduce tinnitus, ringing in the ears. And so we've been doing this now and have a lot of data on this. And this is one of the things that we're doing. I'll just mention we're doing a big study at Stanford now about balance as well. So here, somebody wears a little clip on their collar, and when they tilt, the wristband tells them that they're tilting. And this is important because there's actually a large percentage of people that have a problem with balance and they don't know when they're tilting, and then they can end up falling down. So this is a very simple solution for us that lets people know when they're when they're tilting. We've done this with prosthetic legs, because when somebody gets a prosthetic leg, they have a difficult time learning how to walk because they're not getting any sensation from their leg. And so they have to learn, have to look at their leg and figure out where it is at all times. So we just put sensors into the prosthetic, and then we have people learn how to walk with it, and they can learn how to walk very quickly because now they're getting sensation like they would from their real leg this way. So I got interested in the question of, could we build a completely new kind of sense, not just the clinical things that I've been showing you, but could we build totally new kinds of senses? So an early experiment we did in the lab was we had a participant receiving a real-time stream of data from the internet for 5 seconds. And then 2 buttons appear on the screen, and he chooses a button, and he gets feedback a couple of seconds later. And he doesn't know that what we're feeding him is real-time data from the stock market, and he's making buy and sell decisions. And the feedback is telling him whether that was the right thing or not. And what we're seeing is, can we expand human perception to have a direct perceptual experience of the movements of the stock market? We've done this with Twitter. We can scrape the web for any hashtag and do what's called an automated sentiment analysis, which just means, are people using positive words or negative words or neutral? And this allows a person to feel what's going on and to be plugged into the emotion of thousands of people in real time. And that's a new kind of human experience, because you can now know how the population is feeling. It's a bigger kind of experience than a human can normally have. We're working on detecting things that are there but normally invisible to you. So with an artificial molecular detector, we can do sense, we can do smell, we can detect when there's an odor, and you can feel that exactly like the dog does. So that's something we're working on now. We're doing this with robotic surgery. So instead of having to look up at the monitor, the patient can detect what's going on with the patient just by feeling what's going on with the patient. We've done this with drones, where you're flying a drone and you feel 9 different measures of the drone, what's called the pitch, yaw, roll, orientation, and heading of the drone. Don't worry about the details, but the point is that it's transmitting back to the vest, so you know exactly where the drone is, and that improves the pilot's ability to fly it, so he can fly it in the fog or in the dark, because it's essentially like he is extending his skin up there far away. And of course, imagine taking a modern cockpit, and instead of trying to read the whole thing, you feel it. Because we live in a world of information now, and there's a difference between accessing big data and experiencing it directly. We've done this with, we've done virtual simulations of, for example, what's called a mech suit, where you're inside of the robot. We've done this virtually, where as the thing is walking around, you're feeling exactly as it's moving its arms and as it's stepping and so on. You're feeling all of that information so that you can close the feedback loop between action and perception so you can become one with your device. We're doing this in virtual reality. So here, players are feeling when they're being shot at by someone at a distance in any direction. They're feeling that and experiencing this in real time. And we've also done this, what's called social virtual reality, where people can interact in virtual space and actually touch each other. And when they touch another avatar, you feel it. You feel that you're getting touched. And you know, this, yeah, so this is something that we've been doing. So do you guys watch Westworld in Poland? Has that made that over to Poland? So, okay, great. So I'm a scientific advisor on that show. And so I put the vest into that show. So I now call this Westworld. And here's if anyone saw season 2, episode 7, this is our vest. So it's on the screen here. But if you look at the guy in the middle, you can see the lights come on the vest. And what's going on here is he's feeling the location of the robots, the bad robots. And when he feels their location, he knows what to do there. So here's another scene with the vest. You know, they feel this thing and they turn around and they get killed by a robot. So that tells us that, you know, if artificial intelligence goes bad, my vest won't save you. But anyway, what we've done is we've had many developer contests. So I mention this because if anybody is interested in participating, we've just opened a new developer contest and people do all kinds of things. Here's just one example from the last contest where for blind people, someone put together a glove where it's essentially doing echolocation from the glove, and then you're feeling it on the wristband. So you're feeling where things are around you for blind people. And we've done this in our lab too, for people who are blind, where they're feeling everything going on around them. So this is like what we did in Westworld, except here what they're feeling is where everyone else is, so they know exactly. And on top of that, we can add navigation. So we buzz to go forward and then to go to the side and so on. So we can do that that way. We're also doing this with factories. So, you know, instead of looking at monitors to try to understand what's going on, imagine feeling the state of the factory. It's a very high dimensional system as it's running. And I don't just mean alerts, like, you know, something's wrong, because that's easy. I mean, feeling what's going on with the whole factory as things are, you know, falling behind or moving ahead in this very high dimensional space. So in general, I think there's really no end to the possibilities on the horizon for human expansion. So just imagine, you know, an astronaut being able to feel the overall health of the International Space Station, or having you feel the invisible states of your own health, like your blood sugar or the state of your microbiome, or having 360-degree vision, or seeing in infrared or ultraviolet. So the key is this. I think as we move into the future, we're going to increasingly be able to choose our own peripheral devices. We don't have to wait for Mother Nature's sensory gifts on her timescales anymore. Because like any good parent, what she's given us are the tools to go out to define our own trajectory. So the question now is, how do you want to go out and experience the universe around you? So thank you very much, and I will take any questions.
Thank you very much, David. Thank you for this extremely inspiring lecture. I wish you could hear the applause nor feel it, but of course it's impossible. So we are waiting for the question, but one, if I may, question from me, for you, of course. I have a question about, because you have presented a lot of practical implications of your research. So the question is about, let's say, I'm thinking about using this vest into let's say a therapeutic way, because maybe this vest can improve, let's say, mutual understanding others, other people's emotion, or increasing, let's say, level of empathy, right? Because sometimes people can hear each other but cannot understand each other. Yes, because if you want to understand on the deeper way people, we should also understand their emotions. So I'm thinking about therapeutic implementation of your research and discoveries.
So we've built that, actually. So what we have is a smartwatch that someone wears, and many modern smartwatches can tell, for example, your heartbeat and your heart rate variability and your levels of stress with the galvanic skin response, things like that. And so what we do is we hook up the smartwatch to the wristband so that, okay, so there's two ways we do this. So the simple way, of course, is that you're just feeling all these invisible states of your body. But the more interesting thing is somebody else, like your wife or your husband, wears the watch, and you're feeling the state of their body as an issue of empathy. Now, I have no idea if this is going to be good for marriages or bad for marriages, but the interesting thing is you can be across the nation from somebody and then say, call them, hey, honey, you feel stressed out. Is everything okay? I think it's very interesting to explore this space. We have no idea what the consequences will be of that.
Yeah, I see advantages and disadvantages. But for example, during therapeutic session, I can imagine that this tool could be very, very useful, right? Because in such condition,
exactly.
Under supervision, this solution could be very, very helpful. We have additional question from our viewer, Dorota. Have you done any work on sense of smell?
Yes. So we're working on that now in a couple of different techniques for this. But yes, and I'm very excited about this because right now we're so limited. Humans are much more limited than almost every other animal in what we can smell. But all that information is out there. So I'm very interested in being able to pick up on that, and we can build artificial devices to pick up on that. And once you can pick up on it, it's easy to just feed that in and start developing a clear sense of that. Yeah. I can, if you want, I can just read the questions from the Q&A. So Maria asks, what about people with brain damage? Will we be able to return brain damage to help brain damage in the future? The answer is maybe. There are many different flavors of brain damage, but for example, people who are paralyzed, we're working on something where there are several groups that are putting electrodes into the motor cortex so that they can control a robotic arm. Even though their body is paralyzed, they can control a robotic arm. And what we're working on now is, can we put sensors into that robotic arm so that you feel, either with a chest strap or something like that, or something on the neck, can you feel what the robotic arm is feeling? So that will help that generally. What do you see as the limits? Christian asks, what do you see as the limits of expanding knowledge? Is it a question of overloading the biological brain? Here's what we know so far is that we can add new senses. We don't know how many we can add, but it might be that we can add a sixth, a seventh, an eighth, a ninth. We don't really know what the limits are. And I don't actually think we are going to overload things for a very long time. Why? Because the brain is really good at sharing territory. That's what the brain is extraordinarily good at. So, for example, if a person goes blind, the visual parts of their brain get taken over. And then if they get a surgery that fixes their blindness, then the visual system comes back. And when we add a new sense, that just, takes over some territory, but everything is very good at sharing the territory. So ask me again in a few years if we've figured out where the limits are, but right now everything's open. Alexandra asks, did you try to make research with autistic patients? Yes. So we have a project where the microphone is picking up on the speech of somebody you're talking to, and it does an automatic analysis using machine learning to detect if they're angry or happy or, what their emotion is. And then it tells you what the emotion is. And the reason this matters is because for children with autism, they often have a difficult time understanding what the emotion of the other speaker is. So we've also tried this with video, but I think the audio is probably the simplest way to do it. And so, so stay tuned on that. But that helps a child with autism to understand, oh, this person is angry. Oh, this person is happy, and things like that. And then they can just memorize what to do with that. Axel asks, how's the project going with deaf people? It's going great. So now, when I gave the TED Talk, I was doing that in my laboratory, but now I spun off a company, Neosensory, and that's how we've gotten this all over the world. And so I actually really enjoy now having one foot in academia and one foot in, startup company, because that allows me to take the ideas from the lab and actually have an influence on the world that way. Did you test this device with other senses, for example, senses of other beings? No, although I've had so many questions asking me if people could try this on their dog. I think it's a great idea. We've never done that, but a lot of people have talked about putting a collar on their dog so that their dog can experience something. But I don't have any information about that yet. Are you working on commercialization of your ideas? Yes. So as I said, I spun off a company, Neosensory, and we're a real Silicon Valley company that's been in business for 5 years now. And again, that's been a very nice thing for me to understand how to take an academic idea, and it's a very different world to make a product and ship a product, but it's been a lot of fun to do that. Okay. Great. I'm trying to see if there's any other questions here that I missed. And by the way, I should just mention again, I mentioned this earlier, but if anybody here is a developer and wants to work on this, we have a very easy, what's called an SDK, a software development kit. And you can type, anything that you can detect with other devices, you can feed in here and try to teach yourself a new sense. And you can, we have lots of prizes in our contest, and you can try to win a prize on that. So please keep us posted on that. M asks, what channels do you think might be the most effective to improve human cognitive skills? What might be the most effective data transmission channel? My goal is to read books faster, to write SMS faster, basically to receive and send information almost instantly. Have you any thoughts about that? Yeah. It turns out this probably won't help you to read faster or text faster. There's been a lot of hype, I think, about the idea of implanting electrodes into the brain. For example, Elon Musk's company Neuralink, the idea is implant stuff directly in the brain. And then people think, wow, I could text faster just by thinking about it, or read faster. But the truth is that I don't think people are going to, there's always risk of infection and death on the operating table. And so I don't think people are going to do an open head neurosurgery just so they can text faster or read faster. So I think it's unlikely that that's going to really catch on. So we might be limited in that. But one thing that I love is when I watch YouTube videos or listen to audiobooks, I always do it at a faster pace, like 2x, because the human brain is capable of listening at that. What we're not capable of doing, because of the details of our larynx and our mouth, we can't talk faster than that, but we can listen faster than that. And so I think that's a useful way to take in information that way. Let's see, other questions. Oh yeah, okay. Ada says, I'm a huge fan of Westworld. I have a question whether you drew information for scientific research from art carried out in the art at science paradigm, the activities of Stellark, which Ping Body or Third Hand performed sensory substitution performances in the 90s. I actually don't know Stellark. I don't know what that is. So no, I didn't get inspiration from that, but I will look this up afterwards to see what that is. I'll tell you this. When I thought about doing this, I thought this was a very new idea. But what I discovered after I was already down this road is that, for example, I found a paper from 1923 where somebody was essentially working on the same thing. They took somebody who was deaf and they spoke into a tube, and it was a very long tube that went into the next room, and the deaf person would feel the vibrations against their hand and would see if they could understand what was being said just by the vibration. So it's difficult to ever come up with something that's really new in the world. But so I'm going to look up the Stellark. I'll make a little copy of this and do that. Okay, I'm the developer who's working on VR reality games. I'm hiring 40 people in Poland. Maybe we can test your technology. Great, terrific. Please send me an email. I'm easy to find online. I'd love to hear from you. Yeah. Okay, what are the biggest obstacles you face in your field? Well, that's interesting. One of the things is I have 100 ideas of where I want to go with this, but everything requires lots of work. And just to build something that is, manufactured and all the pieces and parts and everything, it takes years. It actually takes years to make a product to go on the market. And I'm always frustrated by the pace of that, by how slow that is. So I would say that's the biggest obstacle, is just, I wish we could move faster. That's why we started doing developer contests, so that other people can work on ideas in parallel with us. Yeah. Other questions?
I think Wojciech has his hand raised. I don't know if intentionally or not, or
intentionally, because a few years ago, the Junge Symphoniker in Hamburg have made a performance for deaf people who had vests that were transmitting vibrations. Very interesting description of how they felt about that. And there is one called Wooger, actually, which is by one of the companies in the East Coast in US that also does that. And it's supposedly just to experience music in a new way. I had this idea many years ago, but as you say, it's so hard to develop the product that we've never done that.
Yeah, exactly. I think it's an idea that a lot of people have come up with independently. I gave a TED talk on our vest a while ago, and then there have been several companies that have started since that time, like Wooger. But it's an idea that I think has been bubbling around since, like I said, the oldest thing that I have found is in the 1890s in Poland. It's just that the technology wasn't enough to be able to make it happen. Yeah. Oh, there's some questions asked in the chat. Oh, okay. Yeah, sorry, I hadn't seen that. Thank you.
The last one, okay?
Oh, the last one? Okay, great. Okay, let me pick the last one. Okay, well, here, this is a very short one. What are you measuring on your own band? Are you collecting some type of data, and how you're using it? We're not collecting anything. What's interesting about this band, as opposed to Fitbits or other thing, is that we're not collecting data from the band. We're only putting information into the band. So the person is feeling whatever. Yeah, let me see. What was the outcome of the hashtag experiment with Twitter? Nothing, actually. We just did it as a proof of principle. But the truth is that being tapped into Twitter is not terribly useful. I think it would be useful, let's say, for a politician who's giving a speech to millions of people in real time to feel, uh-oh, that went badly, oh, that went well, and so on. But for most of us who are not influencing millions of people at the same moment, it probably doesn't matter too much. Yeah, and someone else asked about, does it help us spread empathy? Yeah, I think so. I mean, I think this issue about, some future version of the hashtag experiment, or this thing I mentioned about somebody wearing the watch and you feeling their physiology, I think all of this can expand us so that we care about other people. Okay, so I'll stop there.
Thank you very much. So thank you once again for your amazing talk, and of course, thank you for answering all the questions. I have to stop in this moment, not because we don't have enough books, but because there is a space for our next guest. But of course, if you have any additional questions, feel free to put in the chat box. So now we come to the second lecture representative from Poland, however, also working for many years in the United States. Piotr Winkelmann, he works at the University of California, San Diego, at our university as well. His research concerns the relation between social cognition, emotion, embodiment, and consciousness. He explores these topics using psychological and biological approaches. Dr. Winkelmann research has been supported by many grants, as you can see, from American institution, but from Polish institution, I hope, as well. He is associated with scientific associations like IPS and SPSP, and editorial boards of scientific top journals such as Journal of Personality and Social Psychology, Personality and Social Psychology Bulletin, Emotion and Psychological Review. He co-edited books Emotion and Consciousness, and also Social Neuroscience. So we would like to kindly ask you, Piotr, for your presentation. Our screen is yours. Piotr, are you with us? Yes, but you are muted.
What about now? Can you hear me loud enough?
Now it's okay.
Good. Okay, let me try to share my screen. And let me just start my presentation. Okay, and then I'm going to share my screen. That's always a challenging thing. So
now it's visible. It's okay.
Yep. You see this, the main screen, not the preview, right?
Yes.
Great. Okay. Okay. Awesome. Let me just see this. Okay. It's always the problem with Zoom. Somehow. Okay. Well, I'll just talk to this. Okay. So, well, first of all, thank you so much for inviting me, and I'm very excited to be sharing my work. It's going to follow up on many aspects that were already discussed. So, particularly on the issue of social perception, understanding emotion, and how potentially technology can help us be better social perceiver and emotional understanders, and perhaps being more empathic. And I come at it for a full disclosure, as a social psychologist, because that's my primary kind of home, is social psychology of emotions. I'm interested in how people perceive emotional stimuli, social gestures, expressions, how such stimuli change our brains and body, how they guide our judgments, behaviors. I'm particularly interested in when the social perception process goes wrong and when you have difficulties. And you can imagine that these difficulties can occur on in multiple situations. We can be on a date and we have a hard time understanding what's going on. What is our date showing? We can have a hard time relating to a person in the interview. We can have a hard time understanding, someone's voice, emotional tone on voice. So there's all sorts of situations where abilities, social skills abilities come to the fore for typical individuals, and particularly, as David has already mentioned, individuals with autism spectrum disorder. So I'm going to zoom in on that a little bit later. So in my talk, I'm going to be much more focusing on theory and basic research and less on technology, for a simple reason that I myself just use technology to do basic research, and I'm not like David involved in all sorts of cool startups and stuff like that, but I use that technology to kind of try to think about how we can design better interventions. So it's going to be I'm going to touch on lots of similar themes, but my goal mostly going to be as a kind of theory, share with you some theory in psychology and social neuroscience that allows us to potentially think about some interventions. Okay, so I'm going to start with a theory, and I don't have quite a picture of a universe, and I was Googling whether I can find a picture of a universe, but I wasn't able to find anything. But I do have a picture relates to another grand theme in science, which is the mind-body problem. So you all know the mind-body problem from Descartes, and a religious person who was really puzzled how an immaterial substance like the soul can interact with the material body. And so he had this very complicated and a crazy scheme that pineal gland is being spun by various fluids, and by spinning pineal gland, the body can signal to the soul. We all know that this is not true, but the problem remains in the sense, how does the immaterial mind interacts with the material body? And the problem is both kind of philosophical, but it's also kind of very practical, because one of the challenges or more difficult things to understand in terms of understanding the mind is how come our mind, which is basically a machine that for abstraction, so a machine can think about abstractly about things like dogs, animals, principles as justice, principles like invisible concepts like indivisible number and so forth, get to this abstraction from a very kind of analog perception. And the traditional solution to this problem of the mind was to think of a process called transduction that was kind of philosophically articulated by Jerry Fodor, the author of the book Modularity of Mind. And he basically had the notion that, what senses are kind of doing their analog processing, but at some point, all these kind of analog sensory information gets turned into something he called the language of thought. So a fancy word for this is that from a model knowledge or perceptually grounded knowledge, we get to these amodal states. And in some sense, that's what the mind is all about. In order for a child to understand mathematics, the child has to first understand that, regardless whether the number 3 is written in numerals, Roman numerals, Latin numerals, whether it's Polish trzy, German drei, it's all 3. So it's a process of abstraction. So everything is an abstraction. So when we're perceiving a dog, we eventually abstract all these senses into kind of beliefs about whether the dog has a leg, tails, barks, pats, and so. But in contrast to this kind of view of a mind as an abstraction machine and eventually thinking being happening in the abstract A model symbol system, we now have these views that are roughly called embodied grounded cognition views, in which the body plays a key role in thinking, perceiving, interacting with the world. And there's various ways of framing these theories of embodiments, and there is a whole spectrum of these theories. So there is a lunatic fringe of embodiment theories that basically just make extreme commitments and tell us that any kind of knowledge is grounded. But the more kind of reasonable way of thinking about it has been expressed by a cognitive scientist named Larry Barsalou, and he has this theory called, or a model or approach called perceptual symbol system, which neuroscientifically can be stated as kind of everything is connected sorry, I'm going to go back to this slide. So everything is connected in that sense that when you think knowledge is not modular, it's not just trapped in a frontal lobe, it's not a model, it's not abstracted, but it's always connected to these perceptual systems. So when we think of a dog, we can what allows us to think about a dog or think about concepts of animals is linking this through sensory states. So, so in a specific case of a dog, we might be linking this to the bark, to the soft feeling of the fur, or to the smell of the dog, or to the visual of the dog. But we can even think about more abstract concepts if we just kind of do some sort of generalization across modalities. And we can also help to use modalities to help us to think about abstract concepts. So kind of a prototypical case of this would be, for example, a concept of time, where we can think about time as in the dimension of space. So the future is in front of us and the past is in the back. We can understand the sense of justice by as a form of balance. It doesn't mean that this is reducible to the sensory sensation. It means that abstraction is just, all you have, all the sense of justice is reducible to a sense of balance. But that's how we can start thinking about it. Okay, so a lot of work in psychology has gone and tried to find out some evidence for the embodiment processes happening in the brain. And some of the work involved technology called fMRI, where we put people in the scanner and we look what activates what people are thinking. So, so in the study on the left here, we see people being shown objects like a hammer or a screwdriver, things like that, and faces. And what these researchers have discovered is that even when people see hammers, they activate premotor cortex, which is initially surprising to these researchers because they didn't expect just in the process of visual perception to see motor activation. But it looks like, perception is very close to action. So a theme that already David mentioned, the closed sensory loop. So that's on the level of very simple perception of very simple objects. That's here, that happens on the level of, perceiving very simple cookies, which probably not surprised that, not only when you're eating a cookie, a gustatory cortex activates, but also when you're seeing a cookie, the same part of the brain that is involved in the consumption of the cookie also activates. But perhaps what's going to be more surprising is that even when you're seeing abstract sentences, so wild horses running across empty fields, or even more abstract sentences about movement of ideas, then parts of the brain that are involved in perception of movement activate. So this is a famous study by Aisha Sagan that basically just shows that motion sentences, both in terms of concrete and abstract sentences, activate the motor cortex. Okay, so it looks like our body activates during the perception of these non-social stimuli. And so today I'm going to be focusing on the perception of social stimuli, particularly perception of things like gestures and facial expressions. But I just want to give you an intuition that this process of embodiment should be particularly pronounced, or should play a particular role in perception of faces and gestures, partly because we have faces and we are able to make gestures. So when we're trying to interpret an ambiguous expression, like here Trump making one of his weird faces, we can engage our own face to simulate and try to make a similar expression or a trait, or try to basically convert a kind of a stimulation of our sensory system into understanding. And as I will show you, that that process of that stimulation and simulation, so generation of this kind of like a new hypothesis and sensory motor hypothesis, helps us understand what's going on. Okay, so I'm particularly interested in how this process works in the domain of facial expressions and gestures. And as you know, and especially as Vupes, where people do lots of work on imitation, imitation is a widespread phenomenon, and it can be seen in all sorts of primate species. It can be seen in birds. There is one paper that won the Ig Nobel Prize that says that there are limits to imitation, and they were not able to find imitation in turtles. And the notion of imitation, of this process of responding with to expressions and gestures with your own body, is assumed to play a big role in cultural transmissions from very simple culture animals. So for example, contagion of emotional states in animals. So a flock can respond adaptively if one scared zebra infects emotionally other zebras, so the whole herd becomes emotionally aroused, to much more complex processes like social learning in children. And for example, accents can be thought of as one example of this kind of hardwiring culture into our brains through an imitative process. So I grew up in Poland. So even though I lived in the United States for 20 years, I still have a Polish accent, which you can think is, depending on you, as you look at it, maybe a good thing, because it still identifies me as a member of my culture, or maybe a bad thing. If I want to become a spy, then I'll be not a very efficient, not a very good American spy, because I'll be easily told as, you know, you sound a bit Russian to me. But it is, of course, there are limits, and not all imitation is just a simple imitation. And so Joe Heinrich talks about, you know, more complex types of imitation, but it is to some extent a secret or success. And imitation is simple in some way. It's neurally simple because it basically, and as David actually mentioned, involves on creation of these perception action loops. So basically, when we see faces, we often make faces. So we smile and someone smiles back at us. We stretch our hand and someone stretches back a hand to us. So that leads to this pairing of sensory and motor neurons, and creates these kind of sometimes inflexible perception action links. So And as a result of creating these links, the imitation can become automatic, encapsulated, and unconscious. And the process starts very early. Again, there's a famous YouTube videos with the baby dancing to Put a Ring on It by Beyonce. And it's remarkably able to make very, very similar expressions. So we become very good at this. So the human see, human does skill are very early, and we are precautious about those skills. All right. So we have those mirror neurons or mirroring processes. I'm not making any commitments to mirror neurons being in the brain, because it can be just anywhere in the brain, and the whole brain is in some sense a mirror system. What I became interested in this kind of automaticity of this imitation process, and as I initially told you, I'm gonna be trying to exploit the automaticity of that imitation process to help individuals with social challenges, do better in emotion perception. But I want to first show you how I use technology, or how we can use technology to explore a little bit learn a little bit about the nature of that imitation and emotion perception process. So I'm going to just mention a couple of studies we did on the imitation of what I call creepy and mindless androids. So they are creepy. So there's two of them I'm going to just mention. So we got access to a robotic head made by Hanson Robotics, and basically what this head can do is basically generate facial expressions. So there's a whole video of this which I won't have time to place, but it basically can move eyes, can shift locations, and can make different facial expressions. And this is just basically using a bunch of actuators in the back of the head. But so what we do in our studies, we show this thing to participants, this thing that looks like Einstein, although in some experiments we dress it up so it doesn't look like Einstein, because we don't want to have an association with Einstein. And we know that participants think of it as a realistic robot, but then also they find it quite creepy. And for our purposes, it's actually good that they find it creepy, because in some sense, what I'm interested in from a theoretical perspective is the automaticity of that imitation process. So let me tell you what happens when people watch this type of robotic head. So we run a bunch of studies. I'm just going to show you one representative ones where we had this robotic head makes angry and happy expressions. So we program it to generate kind of happy and angry expressions. And then we put participants in front of it. And in one experimental condition, we just had participants watch the robot. So they don't have to do anything, they just observe it. And then in another experimental condition, so it's a different group of participants, and we have participants actively make that expression. So we can see what happens when participants just watch it without any instructions to mimic, and what happens in participants' bodies when people have instruction to mimic. And we can link participants' activity to the robot's activity by basically combining two kinds of signals. So we have information from the robot, we know what it's doing, so we have kind of electrical information about the robot. And we also have a signal from participants' faces. So we basically attached sensor electrodes on participants' faces. It's called facial electromyography, and we measure the smiles and their frowns, and we pick up the dynamic of the smile and the frown. So that linkage allows us to then see how faithful is the mirroring and is the imitation. So participants are going to be watching these expressions of the iPad of Einstein frowning and smiling. And what we basically see on this complicated graph, which is I'm just going to walk you through it, is basically a very, very tight linkage between the robotic activity and participants' muscle activity in both the condition when they just watch it, it's spontaneous and intentional. So basically, if you look at the brow, when the robot's brow moves, so that's the leading signal from the robot. So basically expressing anger. You can see that this leads that signal from the robot causes humans to basically have a very close match, even in spontaneous brow activity. So they basically immediately imitate the robot, and they do it very faithfully in terms of all the rise time and the whole dynamic of the signal. The imitation is even stronger in intentional condition, and it's even more faithful, but you can say that this is less interesting because that's what people are told to do. So the key point here is the spontaneity of the mimicry for both the frowns and also the smiles. Okay, so that's not limited to facial expressions. Participants also do it for gestures. And this is particularly interesting because we were able to look in that particular study on whether humans care really about who's doing the expression, or whether they care about the dynamic of the expression itself. So here we looked at gestures. So we took very simple gestures like waving, and you can see that this is a very simple gesture, but the gesture is either made by actual human, an android that is made to look like a human, and a robot. So it's basically the android is basically this robot dressed in human appearance. And it's the same gesture, it's the simple waving gesture, but you can see a little slight differences about the gesture. So the robotic gesture is a little bit more mechanic. It's not perfect, okay? So, so what we were looking at is participants' muscular activity, spontaneous imitation of gesture. So what your hand does when you see a gesture. So what a participant does when the hand is resting, but we were expecting this spontaneous mirroring activity. And we noticed in that study that actually what matters for the amount of imitation, what makes you mirror, is really not who is doing the gesture, but how human-like is the gesture. So if the gesture is human-like but made by robots, then you emit. And if gesture is more robotic, but it's made by a human-like a robot, then humans don't mimic. So humans care about the motion dynamic. So the imitation process seems to not care about artificiality of the model of the emitter or the sender itself. It doesn't care about its artificial lectures, but it cares about the motion dynamics. So this opens the space. This opens the space for well-known stimuli or well-designed stimuli that keep the human dynamics of the motion, but changes its appearance, which becomes important later. Okay, so I mentioned that people kind of imitate mindlessly and spontaneously and without bidding, and that they care about the dynamics of the notion. But I also want to tell you that that the imitation system is in some way clever. That is, when we are chameleons, but we are not blind to who is imitating, why we're doing the imitation, and the chameleon becomes smarter, or we can decompose, or the chameleon becomes sensitive to what's going on. So let me tell you a little bit of how we try to decompose the chameleon and make it smarter. So one thing about social imitation that you probably know, and this is actually one of the biggest challenges in terms of dealing with individuals with disabilities, is that imitation is contextual. So if you are playing a bridge where you have a partner, so these two ladies are on a team and these two ladies are on a team, you know, it would be smart for you to reciprocate your partner's smile, but it would be stupid for you to reciprocate an opponent's smile. And so here we have some sort of example of social intelligence where this woman appears upset and this woman seems happy that this woman is upset, presumably maybe because her upset relates to the fact that she has bad cards. And also, you know, in flirtation, dating situation, or interview situations, you know, for example, you maybe, you know, if you're meeting a Japanese emperor and you want to bow, not exactly at the same time that Japanese emperor bows, or maybe you want to bow even if the Japanese emperor doesn't bow. And there's all sorts of gestures and things that we don't want to replicate, imitate in social life. So, so we use technology to try to understand the smartness of that imitation. So this was a very simple study where we again invited our friend Einstein back to our lab, had people observe him making facial expressions, but we simply put people on teams. And in one example, they were on a team with the robot, with Einstein, and they had to figure out, Einstein knew the outcome of the game, whether a dice showed a positive outcome for you or negative outcome for you, and you had to watch him to find out the outcome. In one case, it was Einstein was a teammate. In that case, a smile meant that something positive happened. In the other case, the frown meant that something negative had happened. But in the other condition, participants were on a different team, and in that case, Einstein's smile meant that something negative happened, and Einstein's frown meant that something positive happened, right? In a very simple kind of a social kind of reversal of the meaning. And again, we looked at muscular activity. I won't show you the complicated waves just to move faster, but basically we show that imitation, the body response to these kind of smiles and frown is very intelligent. So in a cooperation condition, people smile to the robot's smile and frown to the robot's frown, but in a competition condition, participants smile to the robot's frown and frown to the robot's smile. And you see it everywhere. You see this type of intelligence of imitation everywhere. You see it in imitation of gestures, in imitation of facial expressions, imitation of voice. And a lot of parent-child interaction is actually based on the principle of counter-mirroring or counter-imitation. So any parents know that you're supposed to be calm when your child is excited. You're supposed to be excited when a child is calm. And Conrad mentioned therapy, and lots of therapeutic interactions are based on the principle of counter-imitation. So we regulate the people who we interact with. So we use imitation to gain understanding, to improve understanding, but also we use counter-imitation or counter-mirroring to regulate our interactions. So social intelligence is often based on the counter-regulation. I'm going to skip that study. So we are smart chameleons, and we intelligently use imitation. Right. So we intelligently use imitation. And now the question becomes, and this is the key question that for today's lecture, is whether we can use this process of imitation, use this process of this tight coupling between perception and action to help people and become better social perceivers. Okay. So one question that often this work on imitation leaves unanswered is, what is the causal role of this process in social perception? Because it's quite possible that the body signal is just, it's an important signal, it's a useful signal, but it actually, the body processes are not constitutive, are not critical for perception. There's lots of models of face perception that have to do with simple processing of the features. But we have some evidence from various techniques, transcranial magnetic stimulation, from lesion studies, from physical blockage, and even studies using Botox, showing that, for example, the body plays a causal role in perception. And I'm just going to mention one study because it's just a fun study that just recently came out. It involves Botox and makes you think twice about getting Botox. And it's from my it's from my colleague in Belgium, Axel Clearmans, who is very interested in consciousness and especially interested in this phenomenon called change blindness, which is kind of a neuropsychological classic. And basically, the idea is that when changes happen, either slowly or more subtly, people really have a hard time perceiving those changes. So here's an audience participation question. I know that I'm just going to pick on Conrad because I know he was watching this. So Conrad, were you able to detect change?
Sorry, once again, because I have some problems with hearing.
Okay, were you able to detect the change in the expression?
Oh,
no. Okay.
I don't think so. No.
Okay. Well, what about now?
Once again, okay. Now I need to focus. Maybe a little bit. Yes, so yes. Now I see.
So what is it changing from to?
I think at the beginning we had a smile, but very light smile. But here I see angry face.
Yes,
I guess.
Exactly. So you see an angry face, and basically so this is a very simple experiment that basically asks you to tell, just like as I did, what has happened, what expression was at the beginning and what expression was there at the end. And while the task is completely trivial, if you have the time, if you show the beginning and the end state, it's actually very difficult if you doing this in the slow motion. And the idea behind that study was that people who have Botox in the brow area, which is the one type of Botox that I probably will get because I have this pronounced brow and people always think that I'm angry. So that having Botox here deprives you of that feedback that is necessary for perception of that face, to the detection of that face. And indeed, they found that people with Botox have a harder time detecting those changes. So that's a very simple example of kind of the causal evidence for these types of processes. So it's not as fancy as using transcranial magnetic stimulation, where you can look at the timing. Lesions give you a very strong, because these deficits can be much more profound than this kind of subtle deficit. But that shows you that the feedback system is involved in simple perception. And as I mentioned, it's very important, especially for individuals with disabilities, to be able to perceive these more complex expressions, because lots of social inferences draw on social perception. So you probably are all familiar, or at least all psychologists here are familiar with something called the mind in the eyes task, where you are shown these types of faces, and you have to make a decision whether this woman shows desire, is joking, is flustered or convinced, whether this man is alarmed, shy, hostile, or anxious. And I'm sure you can all pass this test unless you had Botox, because that's the point of that study, that participants, this is my colleague Neil and Chartrand from USC. So this is a good Los Angeles study and a good study. My sister loves the study. My sister is a dermatologist, and that's part of her business. So she loves the study partly because she gets to warn patients, that there is a trade-off. There is a potential trade-off in Botox. You might look nicer, may look less angry or less positive, but in those situations where subtle distinctions are important, you might be suffering some, there might be some subtle consequences. All right. So how can we and how do people benefit from understanding? How can we benefit from understanding the link between perception and action, and how can we use technology to help individuals, be better social perceivers? So one area that I'm particularly interested in and I've worked in is individuals with autism spectrum disorders. And I work individuals that are high functioning, that is, they have subtle deficits in emotion perceptions and social understanding. So the old word, we would call those individuals now slightly off, but we know that these individuals have consistent problems with emotion perception of gesture, and lots of understanding, lots of difficulties understanding the context. And traditional work with individuals like this involves basically, giving them, the kids watch Mr. Bean cartoons, and they ask, what does Mr. Bean feel? Or, giving them pictures of facial expressions, and they go through kind of like a simple library of these pictures and learn to label them more correctly. But if there is a mirroring process going on, then we could potentially exploit this perception action loop to help these individuals see better. Okay, so we know that, and we know that because of a lot of work where, and this is just an analog of the robot study with autistic individuals, that just like people spontaneously imitate facial expressions of a robot, autistic individuals do not fail to imitate it. So if you look at this study, which we've done a few years ago, so typical participants, if they just spontaneously shown facial expressions, they spontaneously smile to a smile and frown to a frown. That's using facial EMG. But typical individuals with autism spectrum disorders basically show a flat line. So they don't show spontaneous imitation. Okay, even though they show voluntary imitation, they have no problem making. It's not a motor deficit. It's a spontaneous engagement of this embodiment process deficit. So how could we try to fix this broken mirror? Okay. So we can use technology, and we can use the technology that basically, you are now very familiar with, which draws on the ability to pick up expressions from the face without EMG, without directly looking at the muscle, but looking at areas of the face that contract or expand or change shape as a person makes facial expressions. So Paul Ekman designed a system called facial action coding system, where each action unit in the face is labeled and is basically tied to an emotional expression. So a smile, for example, involves basically curving the lips. So cheek is raised, lips are pulled, and here you have an example of anger. So we have these facial actions, and then we can label those facial actions, okay? And there are people who are employed by companies like Affectiva that spend years, basically using this facial action coding system and teaching computer algorithms to detect these facial action units, and AU1, AU2, AU4, AU5. So these are the names of these various action units. And basically those action units are fed into a neural network, and a computer algorithm designs, basically recognizes the expression by basically looking for those action units. And as you know, there is now lots of these companies. Affectiva is a big one. iMotion is a big one. You can download things on your phone from Affectiva app. Yeah, I just downloaded yesterday. That can analyze, I don't know if you can see it here. Oh, you can't actually. So this is an Affectiva, I think can't analyze it. But anyway, you can download it on that through app, so that it's gonna do your face. So how can we use it? How can you use it to help? Well, you can use it to help by creating these perception action loops in assistance where a participant is watching a screen while the computer recognition algorithm is running on it, and the algorithm can detect facial expressions or just directly feed this into a production system, like a simple avatar. So here you can we can create a system with a loop where the avatar that basically mimics a participant's facial expression. So the participant is basically driving the avatar by making various faces, or the avatar can be an active that can be the generator of facial expressions, and participants are mimicking it. And basically, the long story short is that if you give participants a fairly substantive training, so it would be hundreds of these trials of imitation and perception trials, you can see some benefits. So if you test people on recognition of subtle facial expressions, and you compare pre-test to retest, you see improvements in participants who are correctly imitating the avatar and correctly driving the avatar. Unfortunately, you also see deficits for participants who are bad at this thing. So you can actually mess people's facial expression if you don't give them feedback. So if participants are bad about matching the facial expression of the avatar, that sensory motor training actually leads to a decrease in in expression recognition performance. But that's partly what I wanted to tell you, that lots of this sensation perception action loop work, and there's lots of this work going on right now, basically has a danger of, if you actually creating that loop, you have to make sure that that the imitation process is accurate. All right, so people have been now using this system for a variety of intervention in autism. Again, I was just involved in the preliminary, the basic the research work, but the work that we originally did with Marian Bartlett, who is now part of iMotion, so the Apple, so they left UCSD and went to Apple, designed an intervention which involved what's called an emotion maze, which is a game for kids where kids basically get rewarded for, it's like a Pac-Man for making an correct expression. And if they make a correct expression, they can move on into a maze, and you can program the expressions. You can use real faces, you can see artificial faces, but part of the work with the robot was designed to show that even if you do robotic faces or avatars involving animals, that all works as long as you have the dynamic right, that creates the imitation process. And that leads to improvement both in the production and interpretation of facial expression. There's new work showing that even you can create even this more embodied conversation agent with multimodal emotional stimuli. So you not only have a face, you also have voice, you can also have touch. So that kind of touches on the theme that David mentioned in his talk. And finally, this is something that I was going to ask David, if he's around, about a project that actually comes out of Stanford. I'm not sure if he's involved with this, but this is something that I was going to ask you about it. But I'll just briefly tell, in case you're not involved with this, what the idea was. So the Google Glass is the notion that, kids with autism, might benefit, just like David was talking about, using his watch to help them pick up a tone of voice from the conversation, and giving a child with autism a feedback whether someone is being angry, someone is upset, someone is sad, someone is ironic, someone is happy, and so forth. So Google Glass is this idea that you could give online feedback on subtle expressions. So these systems, the emotion recognition system, the algorithms are so good, and even with this very simple iPhone, they can provide real-time feedback. So basically, glasses would look at your interacting face and would pick up whether there is a smirk on the face, or there's anger, there's sadness, there is fear, and would basically either auditorily or through like a visual icon give the child a label. So a child could interact in the social setting, or would interact in the social setting, and there's some evidence of improvements as a result of these interactions. So David can maybe talk more about the details of that study. I'm just going to finish in a moment, but I'm just going to mention very short intervention, or a very simple intervention that we are doing at UCSD. And we have a bad distinction at my university, at the University of California, San Diego, as being known as University of California Socially Dead. That is, we are #1 in loneliness. So there is this kind of chart here of schools that are good for partying and good for academics. And David would be very happy that Stanford University is definitely good for academics, but it's also pretty good for partying. And I think that's Stanford here, I think, with S. I don't know where UCSD is, but it's pretty good. Oh, here is UCSD. Very good academics, almost as good as Stanford, or just as good as Stanford, but not, unfortunately, a bad choice for a partying school. So in times of pandemics, that becomes an extremely important social issue, loneliness. We have lots of issues, and at UCSD, participants feel like they don't belong. Students feel very dispossessed on campus. There's substance abuse problems. There's depression problems. We have all sorts of problems. So what we've shown in some of our work on lonely people, that they lack this process of spontaneous mimicry, and that as a result of that process, lacking of spontaneous mimicry, these participants might be suffering from, problems with experience sharing, mimicry can be thought as a gateway to empathy. So if you break that process, if you don't have that mirroring between participants, and if it breaks down, you can have problems with experience sharing and also the spreading of loneliness. So James Fowler, who is my colleague at UCSD, has shown that loneliness can travel in social networks, just like depression or health behaviors. People literally, which sounds, of course, ironic that loneliness can be contagious, but it is contagious. So our attempt these days is, try to give people training and on these spontaneous mimicry tasks and see if it's gonna affect loneliness. And we're also working the other way around. We give people social training to reduce loneliness, seeing if it will improve their social mimicry. But the study is very preliminary, so I don't have any results. And I'm going to end simply with maybe a discussion point that, as you know, these technologies for reading facial expressions are now widespread. Conrad probably is running an algorithm on me right now, or on the audience, because you can buy a version of a system from iMotion that will simultaneously monitor 200 facial expressions all on Zoom. So he's probably looking at how many people have fallen asleep, how many people are checking their emails, how many people are enthusiastic. Or knowing Conrad, he might be monitoring for all sorts of stuff that maybe I'm not even supposed to mention here in that chat. So we have these technologies. It raises all sorts of interesting societal questions. It raises questions which we can discuss in the panel of whether once you go beyond individuals with social challenges, the use of these technologies raises issues about, is this a fair type of doping, of having these types of hearing aids appropriate, whether we really should be as enthusiastic as we are at this point about the widespread use of these technologies. So anyway, that's just a point. If you're interested, you can download the Affectiva. So I'm going to close. And in summary, I was hoping, I started big, hoping to convince you that perception of social stimuli involves embodiment. It's not just in the brain. So as I love David's talk and this amazing work, but I think he will have probably no issue saying that there is information in the body or in the sensory and motor system that participates in perception. Well, he said as much, and we can exploit that information. That these links between body and the mind can be kind of automatic, inflexible, but they can be also quite conditional and clever. There's a smart embodiment that they play some causal role. I'm not saying that your mind is in the body, but there is evidence for a causal process, and that we can exploit these perception action links to improve our social skills. So with that, I'll briefly thank my lab and I'm happy to answer questions if there are any questions.
Thank you very much, Piotr, for your interesting lecture, full of scientific data, but also practical implementations. So I see we have two long questions on the chat, but let me start, because my question is maybe simple, short, and but I think quite practical. Can it be said that people with Botox will be less liked, and maybe at the end of the day, loneliness? Do you know any study about it? Because Botox is very popular nowadays in Poland, in the United States, but maybe people don't realize that the consequences of using Botox, because social perception around them could be completely, different. And in fact, there is disadvantages. Maybe it's not, of course, it's risky in terms of medical, of course, maybe, but it's not my subject. But what you said, it's very interesting from this psychological point of view. So do you know any research regarding this issue?
Well, I only know my own study, that the study that I mentioned, that that lonely people have impaired spontaneous facial spontaneous mimicry, especially of smiles. But I think this would be a great study. I mean, I'm all for doing this, whether there is besides just the regular issues with perception of subtle expressions, like the study by Axel Clearmans, whether there are downstream consequences of like people having some sort of an off feeling or some sort of a sense of non-reciprocation in conversation with people, with Botox people. And that leads, of course, it's going to be a minor contributor to loneliness, but we know, even from interpersonal experience, I mean, we know from autistic participants, I mean, I know it very well because I talk to these kids at school, you know, that part of, I mean, when you're 10 years old or 11 years old and you're on a spectrum, you know, the kids, other kids don't want to interact with you, and you ask them, why don't you don't want to interact with this kid? He's weird. I mean, what do you mean? He's just, you know, I say something funny, and he laughs, but it's like later, or he would make a weird face, or there's something like off about his time. They have a hard time putting their the finger what it is, but there's something off, right? And social awkwardness is basically that feeling of something off. So whether it's a date, it's an interpersonal interview, it's an interaction at school, that sense of timing is very important, both in terms of the perception and also like the active production. So I think it would be a great study. So if anyone wants to do this study on whether the before and after Botox and loneliness study, I'll be very happy to be involved.
But we need a big grant to buy a lot of, you know, Botox.
No, I mean, that is easy because like my sister, well, that part is easy because we just contact a dermatologist, and the problem is that people will have to fill out, and there is a questionnaire, a standardized questionnaire for measuring loneliness. So if we could get the people to fill out the questionnaire on loneliness before and after, that would be great.
Okay, thank you. But I think the similar mechanism is in terms of robots, because we observe lots of fears towards robots, maybe because they don't imitate us in a realistic way, right? And vice versa. Okay, can you look at the chat? Maybe.
Yeah, I am. I'm reading the.
So we have a time for one question.
Let me see. Oh my God. Let me see, because I just see a lot of the.
At the end, you
okay, so Lisa Feldman Barrett. Okay, the prediction simulation. All right. So yeah. So for someone, I don't know actually from all panels. I don't see who asked that question, but whoever asked the question about Lisa Feldman Barrett, I actually don't see on my chat who asked that question, but it's a great question. So, and it's a teaching moment for me, and this is really interesting. So there is the viewpoint that I presented with this kind of facial action units and, you know, decoding faces is basically based on this theory by Paul Ekman, who you know, is a researcher at UCSF, and he might have retired, who's very well known, and we teach him in psychology classes, and he has this theory called basic emotion theory, and says that there is kind of universal set of basic facial expressions, and there are these kind of hard-coded, he called it fixed action patterns, or although it's unclear whether he's really committed to the word fixed, but there is this notion that that there is something universally detectable about a pattern of facial configuration, or maybe a pattern of physiology that allows us to say that's a smile, or that's an anger, that's fear. And that's AI is built on that assumption. And lots of people, especially Lisa Feldman Barrett, are challenging this assumption. So even challenging the basic research. So for example, they go to a different culture and show that a configuration that looks like a smile is actually not used as a smile. And a classic example, and it's slightly inappropriate, but I'll go for it anyway. There's because it always comes up in emotion conferences, is if you have picture of people's expressions while they're undergoing severe pain surgery or they having sex, it's very hard to tell which one is the one from the surgery, which one is the one from people having sex. And you could dismiss it saying, well, these are intense emotional experiences, that's just the face is crunched. But it tells you, but there's work like that that shows that facial configuration is really, except in those kind of more kind of really, it's less cartoonish that this basic emotion theory would tell us. So Lisa Feldman Barrett has an alternative theory that shows that we construct interpretation of emotional expressions, and our brain constructs the interpretation of emotions based on a variety of cues that are culturally dependent and conceptually depending on the concepts that you have available. So if you don't have a concept of anger or fear, or if you live in a culture that doesn't have a concept of jealousy or even or envy, you will experience and show that emotion in a very, very different way. So I think AI is going to run into this problem, and Affectiva tries to solve this problem by having databases from different cultures and putting all sorts of conditions on when a relevant data set is usable. But in some sense, it's chasing the human psychology. So I'd say that there are real dangers in actually going with this basic emotion theory and using those algorithms in a context non-specific way. And anyone who's Polish knows that a default Eastern European expression is being slightly upset, right? It doesn't mean that we're upset. It just means that we're thinking, right, Konrad?
Completely agree. Okay. I think we have to stop at this point. Now
I apologize I'm very happy to.
Yeah, don't worry.
Email me these questions, or maybe they come back.
Or maybe during our panel we will find the time to answer those questions. So this is the moment when I would like to delegate leadership over over next part of our meeting to Professor Filiciak, but before I make it, let me say a few words about our moderator. I asked Professor Filiciak to be a moderator due to his big knowledge, but also cultural background. So Professor Mirosław Filiciak, Director of the Institute of Humanities, Dean of the Faculty of Arts and Social Sciences in Warsaw. His research interests include the internet, computer games, transformation of television, contemporary culture, and informal distribution of information. Media expert interested in the relationship between new media and cultural participation. He was the principal investigation on, as you can see, numerous research projects and author or co-author of several books on the relationship between cultural and digital transformation. So Mirosław Filiciak, the next part of our meeting is under your control. Thank you.
Okay, thank you very much, Konrad. And yeah, I'm just host here, so I will introduce our guests soon. We had two fascinating lectures, and now I think that more of interesting stuff is coming. Our guests are Władysław Duch. He's the head of Neurocognitive Laboratory in the Center of Modern Interdisciplinary Technologies and the Neuroinformatics and Artificial Intelligence Group in the University Center of Excellence Dynamics mathematical analysis and artificial intelligence. He also works at the Department of Informatics at Nicolaus Copernicus University in Toruń. And he served as the president of the European Neural Network Society for 2 terms from 2014 to 2015. He served as the Deputy Minister for Science and Higher Education and of Poland. Another guest is Monika Gori. She's the principal investigator of the unit for visually impaired people of the Italian Institute of Technology. She's an experimental psychologist with a PhD in humanoid technologies. And she's also an expert on development, multisensory integration, rehabilitation, and visual disability. In 2012, she won the TR35 prize for young innovators, and in 2020 she won an ERC STG with her MySpace project. And the third guest and third discutant is Przemysław Kuśmierek, an entrepreneur and founder of Migam, a company facilitating communication between businesses and hearing impaired clients. And Mr. Kuśmierek is also a founder of Work Without Barriers, Praca bez barier EU, and a video contact center platform OMI, enabling effective online communication, sales, and customer service for businesses and clients. And he's also a founding member of Polish Crowdfunding Society and an active participant in numerous events devoted to innovation. And okay, let's start. And as Konrad already said, my background is within cultural studies. And at the beginning of this evening, I felt a bit nervous in this company, but then I heard the word Umwelt, and it made me feel much more comfortable. And later, Piotr Winkelmann mentioned the broader social and cultural consequences of technologies which were discussed. And I think it's very important, especially in an era of mass surveillance. And those are topics I'm very interested in. But let's start with something else. I'm very curious how the technologies and phenomena mentioned before apply to the areas of our guests' activity. And if we could start with Monika. Monika, you are working with children and infants with visual impairment. The question is simple: how do you help them?
Okay, so yes, hello everybody. Yes, I'm mainly working with children and now also infants and toddlers with visual impairment. So I think that technology and technological solutions for visually impaired people is very important, especially to be used during the first period of life. There are some examples as the sensory substitution devices that David presented in his nice talk that can be used to substitute or in some cases to enhance sensory abilities. My work is mainly related to the creation of new opportunities for visually impaired children in order to improve their motor abilities, social interactions, and sensory abilities. So, for example, visually impaired people and particularly children, they have a lot of delays in many skills, such as reaching for objects or start navigating. And we are working with hospitals in order to create new technological solutions that are based on their rehabilitation protocols that are adapted to technological solutions to improve these kind of skills. So in my case, technology is used mainly in rehabilitation settings and developed with rehabilitators and doctors, medical doctors. Yeah.
Okay, thank you very much. I would like to add just one question, because I'm very curious, and it's not my field of expertise, but I'm very curious because you told about new opportunities, but how does those technologies impact the children you work with? Because I could imagine that this translation of senses, if I could say, has its own consequences. For example, in example, sign languages are more and more often treated as a different languages who create kind of different cultures, not just simple translation of like Polish or English. So how does it work in your field of expertise?
Yes. So in my case, I will make an example. A new device we have developed is an audio bracelet for interaction. So let's imagine if you are sighted, when you move your arm, you can see your arm moving. This visual feedback associated with the body movement is very important during the first period of life in order to understand that this is my hand. And then I can use it to reach for objects, to interact with others. If you're blind, when you move the hand, you cannot see it. But if you put the sound here, then you can listen it. And you can recover your sensory feedback about body movement. By listening your body movement, then you can understand that this is your arm and you can start to use it. And if other people is using the sound, after that you understand how your body is moving and is producing the sound, you can start to understand also other people making movements and you can improve interaction. So with this idea, we have developed this device. It is called ABI. And this device is now a medical device. And we also are trying to open a startup to sell it because, it is useful for improving social and motor skills for visually impaired children. So in practical activities, for example, with this device, we have developed many games in which children can play together. Groups of blind children can play together. And this is it's amazing to see a group of blind children playing together to, for example, catch the flag or other games that are typically for sighted children. Just because you provided them a new sensory information that they can understand and use to interact with others. So this is a very simple idea we had. We are developing many others. I'm mainly based on developing sensory systems that provide multisensory feedbacks, so usually auditory and tactile, and that can be used by more children to improve social interactions, mainly during games. Because I think that rehabilitation during game, if they can play and being rehabilitated at the same time, they are rehabilitated and they have fun. So I think this is a good approach.
Okay, thank you very much. I'd also like to ask Przemysław Kuśmierek, Przemysław, how do you work with these challenges at MIGAM? We have different sense with your job. So please tell us at the beginning a little bit about it.
Yes. Hello. First of all, thank you for. Może tak. Dziękuję za możliwość wypowiedzenia się w polskim języku. Jeżeli możecie się Państwo przełączyć na język angielski, to się prawie nigdy nie zdarza. Super, że tak jest, bo to jest dokładnie nasz obszar mojej pracy. To, co my robimy, my tłumaczymy, dzwonimy od lat w imieniu osób głuchych, łącząc się tak jak my w tej chwili, przez system do wideo połączeń, gdzie ktoś w naszym imieniu, w naszym pierwszym języku dla osób głuchych, językiem pierwszym jest język migowy, tłumaczy coś na języki foniczne. I to, co my robimy, co nas charakteryzuje, to niestety nie mam takich dokonań jak Państwo, chociaż od 10 lat staram się automatyzować język migowy w sposób automatyczny, to my, z czego chyba dzisiaj jesteśmy dumni, to udaje nam się komercjalizować tą wiedzę. I badania, rozwój, które my prowadzimy, próbujemy tak przekazać swoją wartość, żeby model, w którym pracujemy, był przynajmniej 2 razy win-win. Co to znaczy? Podam może przykład. Nasza firma zajmuje się tłumaczeniami na język migowy. Jednym z większych problemów osób głuchych w Polsce jest oczywiście edukacja i praca. Mamy około 80% bezrobocie wśród osób głuchych w Polsce. Wynika to z banalnego powodu, bo jeżeli gdzieś wysyłam CV, w kontakcie mam możliwość pisania kontakt tylko SMS, to nie znam rekrutera, który by napisał SMS-a do osoby szukającej pracy. Szukam dobrej pracy, jestem informatykiem, to jest prawdziwy przykład, jestem inżynierem sieci. Nie mogę porozmawiać przez telefon i dzwoni do mnie rekruter z pytaniem o potwierdzenie godziny, o której my się spotkamy, to jeżeli bierze nasza mama, szansa, że zostaniemy zaproszeni na tą rekrutację jest bardzo mała. My wzięliśmy cały proces onboardingu i szukania pracowników na siebie. Do tej chwili pomogliśmy firmom znaleźć kilkudziesięciu pracowników dobrze płatnych. Warunek jest taki, abyśmy my byli pomiędzy pracownikiem i pracodawcą. I dlaczego to jest model win-win? Ponieważ oczywistym jest, że jeżeli ktoś nie ma pracy i ją znajdzie, to zyskuje. Pracodawca, zatrudniając głuchą osobę, uzyskuje tak naprawdę bardzo lojalnego pracownika. Średnia odejść z pracy wśród osób głuchych jest dużo niższa niż osób słyszących. Tak naprawdę państwo zyskuje, bo aktywizujemy osobę, która była bezrobotna, dzisiaj pracuje, więc zaczyna płacić podatki. Nie musi państwo dla takiej osoby dopłacać, a pracodawca jeszcze dodatkowo dostaje z tego typu grant, a my wystawiamy faktury. I to powoduje, że 4 przynajmniej strony zyskują. I ja bardzo długo walczyłem o to, żeby spróbować wejść na rynek z czymś, co czujemy, że fajne, odpowiedzialne społecznie, tylko kto ma na to zapłacić? Nie istnieje coś takiego jak darmowe obiady. Ktoś musi za ten obiad zapłacić. Więc to, co nas wyróżnia, to my szukamy takiego modelu biznesowego, w którym mamy kilka wygrywających stron, tak żeby ta strona, ta druga pani, tak jak pan Piotr powiedział, ta druga pani jest w naszej drużynie, to ona się do nas uśmiecha, to my razem jesteśmy po jednej stronie, wzbudza się empatia i to, co powiedział Dawid, wkurzało nas strasznie, że robimy bardzo fajne rzeczy w badaniach i w rozwoju, ale trwało to za długo i kto ma na koniec dnia za to zapłacić? Model social impactowy, biznes odpowiedzialny społecznie, który pozwala łączyć kilka stron, może się po prostu opłacać, a żeby zmienić świat, no niestety na to trzeba wykładać pieniądze i to jest to, co my robimy w nim.
To dopytam jeszcze tak i pozwolę sobie, bo tak może będzie prościej. W tym wypadku tak szybko zadam jeszcze to pytanie uzupełniające po polsku, ale chciałem zapytać właśnie o tutaj, no właśnie, skalę działań w Polsce, bo faktycznie wiem, że tego typu rozwiązania, tak jak wcześniej, nie wiem, wprowadzany kilka lat temu audyt dostępności chociażby stron internetowych, to napotykało na problemy, więc jak to wygląda konkretnie?
No my w tej chwili przeprowadzamy tysiące tłumaczeń przez online'owych miesięcznie. Pracujemy bardzo fajnych firm, takich jak T-Mobile, Samsung, firm, które zrozumiały, że głuchy też jest ich klientem, tylko dzięki nam ich obsługują. Na świecie mamy około 72 milionów osób, dla których język migowy jest pierwszym językiem i na całym świecie tak naprawdę traktuje się to jako koszt. To państwo w jakiś sposób płaci za obsługę osoby głuchej. W naszym wypadku to firmy, przez to, że mają korzyść z obsługi, bo to są ich klienci, którzy kupują ich produkty, to te firmy płacą nam naprawdę nieduże pieniądze za obsługę. Osoba głucha ma za darmo tą usługę i tak to działa. Co mnie bardzo cieszy, średnia ocen przeprowadzonych, każde tłumaczenie może być ocenione. Tych ocen mamy 1000 miesięcznie, jest 4,9 na 5. W mojej firmie ponad połowa pracowników to osoby głuche i to głusi dla głuchych projektują usługi, a technologia dzisiaj jest taka. Dzisiaj mamy 4. system. Technologia się bardzo zmienia, jesteśmy zwinni, umiemy się dostosować, ale na koniec dnia chodzi o biznes model. Taki win-win to jest To jest chyba to, o co chodzi, ale rzeczywiście ustawodawstwo w Polsce dzisiaj nam pomaga.
Dziękuję. Okay, so we started talking about projects which resolve very real problems of people with different kind of impairments, but probably a few dozen minutes ago, Władysław Duch, you mentioned that the commercially available products enhancing our senses. And of course, it's a growing market. Now, this immersion commercial products for gamers, for example. So, could we speculate at this moment a little bit? Do you think those technologies could result in evolving new ways of communication and broader impact on our society? How do you think about it? Sorry for making the scale and moving, making this big zoom out, but yeah, that's right.
Of course, money is in games, as we know. So this is what is going to happen pretty soon. But let me comment on the few things that I just heard. I mean, this is a really exciting meeting. And, about the deaf people, for example, we had a big grant with people in the World Institute of Hearing, which is close to Warsaw in Kajetane, where they do a lot of cochlear implants. Now, some children, after having cochlear implants, are very good, and they have organized several concerts. Unbelievable, because after 6 months of having an impact, a completely deaf child could play an instrument, not too well, but some of them a few years after that, and they came from all over the world, from Australia, US, everywhere. And I think it's an incredible success of the Institute. That these cochlear implants are working so well. But some children have problems learning language. And so the question is, what can we do about that? I got interested in infants and learning languages some years ago when I was in Japan, and I found that Japanese cannot learn English because they cannot hear it, right? It's a well-known phenomenon that the phonetics of Japanese is well, rather simple, while phonetics of Polish language is one of the most complicated, most complex. And so I thought, okay, we should start doing research on infants, and we've established a baby lab, monitoring how infants learn language. And the prevalent idea is that you have to have a human interacting with a child to teach the child to hear properly, let's say Chinese or some other language. But my idea was that it's just a question of rewarding children after you see that they react. And so I wanted to automatize that. And we've done a lot of experiments with EEG, with eye tracking, with kind of place on the screen. So the children were hearing something is coming from the right or from the left, because once it's E and once it's E, which is like 5 different French consonants, very difficult for our ears. Well, it has 2 aspects. One is that I would like to really have it on the market, which is a long story. We've got some gold medals on some invention fairs, etc. But we have something that we can show, but really not a finished product, which should not be with computer screen, but it should be with like a toy. So that's one aspect about deaf people. And so our baby lab is actually used now also by people who use gestures. We want to understand whether if you teach children gestures when they're very small, there are lots of books about that. Will they be faster in acquiring language? Will that slow it down? I mean, all these basic things. And in the lab, lots of different things are being done right now. Also watching people walking and trying to use it for diagnosis. We have fMRI and work on working memory and long-term neuroplasticity, actually, because it's fun to transmit information to the brain, but we have to find out what are the best conditions to do that and how to increase neuroplasticity so that the brain will quickly learn what we are transmitting. Lots of things related to that. And I wanted to comment on Professor Winkelmann's, discovery, let's say, because I'm not sure what's the cause and what's the effect. And this is the problem that we frequently have, of course. When you see people who are sad, they don't have many interactions. And so you may say, okay, they don't smile and they don't have friends, right? There is a syndrome called Möbius syndrome where the face is completely paralyzed. And I once heard a talk on that. And it seems that these people have learned to use their bodies, movements, just to compensate, because they're very well aware that they cannot move their face. And that is kind of a shocking experience when you meet people like that. So the question is, well, if they can do this, maybe we can learn from them how to, well, use it more widely for people who feel lonely, how to teach them proper behavior somehow. But that's just a side comment. Lots of different things that we still hope to do. And one, of course, which is very fashionable now, is to use neuromodulation. So not only that we would like to, well, have external additional senses, which is a great idea, but we would like to modulate the processes in the brain so that certain things will be learned faster. I'm also not very enthusiastic about Elon Musk's idea that you'll have lots of nanowires in your brain, unless you have severe epilepsy, and then they do things like that already. I mean, people in Mayo Clinic, for example, some of them have hundreds of nanowires, and there is one group in Poland now in Wrocław that have repeated this kind of procedures with people suffering for severe epilepsy. But I think it's much more promising to think about changing the way the brains are working. So we have a group doing mathematical analysis of EEG so that we can more precisely localize the sources. And then we have TMS, which is really high power machine, like 5 megawatts in an impulse, incredible big machine. And of course, all kinds of DCS stuff. And you want to really increase the information flow between different parts of the brain. If we can understand that, then we can influence the brain to analyze the senses much better. This quantization of what we hear, what we feel, etc., more precisely. So that's something that well, we've got the equipment, and then COVID got us. So we cannot unpack it because we need people from US to come and install it, and they don't want to come because they cannot travel now without the quarantine and other stuff like that. So for last year, the lab has been kind of, very slowly moving, I must say. But I have big hopes for using new sensors. There is one company in Gdańsk now which has an excellent sensor measuring like 7 different things, which you just put on your chest. And I think we can use it to analyze how excited are people when they learn things, when they actually play some games, etc., in real time. And of course, there are lots of dangers related to it, as you know. I mean, politicians are going to say everything that you want to hear if they would get this information real time. That is already happening. Even in Poland, there is a lab that tries to analyze reactions of people to what politicians say. And I think it is really terrible for the politics because people are just hearing lies all the time because then they will get elected, and this is all they care about. And I think there's lots of problems coming because of this kind of research.
Yeah, I think it's a great issue, a very interesting one. This, those dangers, those dangers, how to not to cross the line, how could we maybe yeah, maybe I should ask you also as a former minister, what about our responsibilities towards society as a scientist? How can we be sure that consequences of this research won't do us more harm than good? I know this is a very broad philosophical question.
Yes, well, I've heard actually this morning information about Bhutan, which is one of the countries which is measuring the happiness of people instead of measuring GDP, as you know. And they said that, well, you just need to have wise leaders, because their leaders happen to have degrees from good universities abroad, and especially in medicine. And so they have actually vaccinated already the whole population, which is slightly less than 1 million. So it's really amazing. And unfortunately, I don't see good leaders in most European countries. I see a good change in US, but we still suffer from the leaders that we have.
Okay, so let's move beyond politics, or maybe beyond politics in direct understanding, because I would like to move back to Monica, because you are what you are told us about your work, it sounds great, and what I think is how can we make all those great devices available to all people in need? So could you tell us a bit about the greatest challenges in your work? From one side, of course, scientific ones, but also how to make those devices available, those practices, those cures.
Yes. So as also David Eggman said before, giving the possibility to the device to be available to everybody is not simple, mainly because we need to sell it, and to sell it we have to find, a good set of opportunities. So we are now working on this because, I think that, for example, the devices we are developing could be very useful for children, and so that is that is a hope, but it is not simple. In the meantime, we are using most of them in the hospitals in which we work with children, and we are also testing at the neuroscientific level how the use of this device. My idea is that every kind of technology should be based on neuroscience and should validate it with neuroscientific approaches. That's because otherwise it is very difficult to say if the technology is useful or not. So for this reason, we usually start from at least for what concerns rehabilitation, because for me rehabilitation is associated with cortical plasticity. So if a system has been rehabilitated, then also at the cortical level should be possible to see the change that has been provided. So that's my approach. I wanted to investigate. I usually work with the EEG and behavioral psychophysics in order to understand how the child without disability develop. A few years ago, in 2008, I published a paper in which I showed that multisensory integration developed late, about 8-10 years of age, and before children uses one sense at a time, so they are not able to integrate. So there are now evidence that in some specific cases, children can also integrate multisensory information of simple kind, but what we have demonstrated is that during the development, different sensory modalities are crucial to teach to the other sensory modalities. And this neuroscientific finding is important because then if you don't have a sensory modality that is necessary to train the others, then you cannot train that modalities. And then, for example, a blind child is not able to listen specific skills, specific sounds that for which vision is important during the development. So in some way it changes the idea that blind people have always enhanced skills with respect to others. But what we demonstrated is that the skills that are enhanced are those for which, this is what I think, vision is not important during the development. So it is important to understand how we can substitute vision in which specific task. So multisensory integration is not always useful, but depends on the kind of task you have to perform. So you have to understand when it is useful, how you have to use it, and then you have to demonstrate that the use of a new sensory system is beneficial for the child. And you can demonstrate this by doing trainings. So by let the child using the device for 3 months, for example, 1 hour per day, and then you can measure how it changes on many skills at the physical level, auditory, psychoacoustics, motor kinematics, EEG at the cortical level. And yeah, after this, I can say, yes, this is a useful technology. And yeah, I can sell it because it is useful.
Okay, and how, in the perfect ideal world, which unfortunately doesn't exist, but let's speculate, when your technology is ready, what would be the perfect application? Would you like to, to put it into schools and do some, I don't know, peer mentoring system about it, children learning with other children? How
we have different technological solutions for different different fields. We have worked on robotic platforms for learning mathematics at school. So in the WeGrow project, we have developed with a big network of centers in Europe some platforms to teach, for example, the Cartesian plane, understanding Cartesian coordinates, angles, fractions, and many others. So it would be nice to have a set of devices to be distributed that can improve many aspects of the development. I also, as I said, I'm working on rehabilitation. So firstly, rehabilitation settings. Secondly, education, so at school. But then I also think about activities such as football, sport activities, because I also think that, as I said before, there are evidence, and we are working with many football players. Football, for example, is a natural training because football blind players are people that can learn to move in the environment. They learn to interact with others. They seem societal people, are like echolocators, more or less, and they are just trained doing football. So I think that sport is another natural training in which specific technology can be very useful because, again, children can have fun and at the same time they can be rehabilitated.
Okay, thank you very much. And we have at the chat, we have also questions to Przemysław Kuśmierek, which continue the issue of availability of those supporting technologies and services. And could you tell us a little bit about it? We have this question from Marcin T. About how make those technologies you offer more available, but also maybe you are aware of some new initiatives. For example, Marcin asks about new platforms for education and gaming for deaf people. Are you aware of such initiatives in Poland, or maybe we have some examples of good practices somewhere else?
Jeżeli pozwolicie, to dalej chciałbym w języku polskim odpowiedzieć. To rzeczywiście bardzo dużo dobrych zmian w tej chwili następuje w Polsce. Mówiąc o kosztach, to udało nam się zejść do kwot między 25 a $100 miesięcznie za obsługę Uniwersytetu Języków Migowych. Więc to są już tak małe koszty, że da się to zrobić, naprawdę nie boli. Więc koszty dzisiejsze versus to, co było 10 lat temu, to są prawie 100 razy niższe. Więc to w bardzo dobrą stronę idzie. Jeśli chodzi o inne inicjatywy, no to sam znam kilkanaście osób głównych, którzy pozakładali swoje działalności od małych, rozwinęły się. W tym przypadku znajomość języka migowego jest po prostu korzyścią. Mamy w organizacji Człowieka, który założył Centrum Finansowe Głuche. On w tej chwili chyba z 80% wszystkich kredytów i ubezpieczeń w Polsce, które biorą osoby głuche, a tych osób jest kilkaset tysięcy, on je obsługuje. Jeżeli mówimy o edukacji, to chcę pochwalić nasz MEN. Opublikowali chyba z 2 tygodnie temu po raz pierwszy darmowe, dobrze przygotowane podręczniki do nauki języka migowego dla klas 1-8. Zrobili to z Instytutem Lingwistyki Migowej z Uniwersytetu Warszawskiego. Cały materiał po raz pierwszy jest przygotowany przez głuchych metodyków. Do tej pory było tak, że osoby słyszące mówiły, w jaki sposób będziemy uczyć osoby głuche. To się nie mogło udać. W końcu jest tak, że to głusi o głuchych decydują, więc z punktu widzenia, w którą stronę idzie, to się zmienia, to super. Jeśli chodzi o gaming, to niestety za wiele nie wiem, ale wiem na przykład, że w Australii większość prac związanych z monitoringiem, obserwowaniem tego, co się dzieje na monitorze, wykonują osoby głuche, bo robią to lepiej. Statystycznie mają mniej wypadków samochodowych, bo widzą więcej szczegółów. Więc z mojego punktu widzenia staramy się wykorzystać te braki, które powoduje pewnego rodzaju niepełnosprawność, bo w odpowiedni sposób przedstawione jest to po prostu korzyść. Nie wiem, czy odpowiedziałem na pytanie, ale to jest dokładnie nasz punkt widzenia.
Okay, thank you very much. Maybe some other of our panelists would like to add something, or maybe, of course, our David and Piotr are also very welcome. So if you add something to the issues we discuss, you are welcome. But at the same time, yeah, okay, David and Władysław, okay.
Oh, I don't have anything to add. Yeah.
Okay, Władysław, please.
I just wanted to say that one spin-off that has resulted from the work in my lab is devoted to creation of diagnostic and therapeutic programs for people who suffer from dyscalculia. And lots of experiments have been done with people. It's amazing to see, adolescent person who cannot say whether 5 is bigger than 3 or something like that. But they have produced also a program that they want to distribute also in China and other places, which is based on the idea that you have to link the spatial position with the numbers, that spatial cognition and mathematical cognition is linked. And there are some ideas behind that. So that's another thing, doing interesting applications that may help people with all kinds of disabilities. Also, we have a very good a preschool for autistic children in Gdańsk, and it's a kind of a research center also that is providing expertise to other countries around Poland and in Scandinavia. And they're mostly using this ABBA approach, the behavioral techniques. But I think they're interesting ideas that come from our understanding of neuroplasticity and simulation of what happens in the brain that I hope in near future we'll be able to test in real experiments, not just now with the computer experiments. So I see this idea that people are in computational neuroscience trying to understand more and more complex ideas. I've written a paper on conspiracy theories. Nobody wants to publish that because it doesn't fit to anything, right? It's not a simple experiment. It's not very sophisticated simulation, but I think it's important to focus not just on programs which learn better and better. This is what we do in computer science, but also on the programs that can replicate all kinds of errors, human errors, related to memetics, related to how we absorb information and why we absorb information and why the conspiracy theories are formed in human brains. And so there are several ideas that we can test in computer, in silico, but we don't have yet any experiments. And so most journals, I did send it to 5 journals. I haven't got any journal that has sent that to a reviewer, because they just look at that and say, well, it just doesn't fit to what we do, right?
I think there was a conspiracy against your paper.
That must be the conspiracy, right?
Okay, so
I could put it in psych archives and other places, yes. But interesting that we don't have journals which are at this level of well, speculations, yes, but something that can be tested experimentally later that will show us whether some ideas related to high level cognition and rather complex things are true or not. And well.
Okay.
May I ask a question to David Eagleman?
Sure.
It goes back to this earlier question that I was asking, but I'm very interested in what he will say from a kind of a, given that he's working much more with practical application of this emotion stuff. So because this is beautiful work, like, and the ideas of, for example, trying to sense remotely someone's state. You gave the example of, you could see whether your wife is distressed or not based on a physiological signature. And I know people at UCSD, I didn't actually realize that you did your postdoc at UCSD at the Salk. I just, I remember it. So there's some person at UCSD that's working on the project of parents monitoring their kids' state using a wristwatch, and which for kids with autism is very important because the kids can go to school, like Virginia, like you mentioned, these schools for kids with autism, they can go through very stressful experiences and parents are able to monitor and have this kind of early warning system. And sometimes teachers will not tell you that a child got very distressed. So if you have this wristwatch with a state, that can be a very useful information. But provocatively, if Lisa Feldman Barrett is correct in her notion that there is really no physiological specificity, you could be calling your wife saying, honey, you're distressed, but in fact, she's in an aroused and emotionally excited state for a very different reason.
I'd probably want to call and interrupt that anyway, yeah.
Honest, that's a good point. But you must be faced with this problem all the time. Because even with faces, which are probably the most specific emotional signal, or voices that are most specific emotion, we have these problems of interpretation. But how do you deal with this problem that these physiological signals are so non-specific?
Yeah, I think they actually are quite specific. So, we might not be able to tell the difference between arousal or stress or excitement, but as we get better and better at measuring things, and, labs all around the world are developing biosensors that are, transparent films that can sit on the skin that can detect actually, molecules that are secreted, as well as, of course, things like electrical signals like the galvanic skin response. I think we're only going to get more and more refined on it. I don't think that these, let me do it this way. I think these signals are universal. They're not culturally defined or something. And so it is the case that you would be able to tell when somebody is stressed versus aroused, let's say. And to the degree we can do that now, we will only get better at that.
Okay.
So I hope I'm answering the question that you asked.
No, you are definitely answering, but you're putting yourself on the kind of more of an Ekman side rather than Lisa Feldman Barrett side, from the perspective of, or Ralph Adolph's side versus Lisa Feldman. Ralph Adolph is another defender of that there is hope for emotional specificity. Yeah, because there are some people who think it's a hopeless project. Maybe the only hope is to just find enough contextual modulators, and because you can get stressed when stress can be exciting. For example, there's some people at UCSF that work on or even at your at Stanford neuroscience. There's this notion of this kind of exciting stress. Like some work with rhesus monkeys that works on kind of the positive stress. Mm-hmm. Go ahead.
I mean, I agree with you. And, you know, we're working with some developers who are doing this thing I mentioned when we're using the watch to tell, you know, the auditory emotion of the speaker that you're talking with. But of course, there's some error rate. There's a pretty large error rate in that, not surprisingly. So I think we'll only get better and better as we take in more signals, including video and audio and maybe other contextual things. Yeah.
How about deception? I'm sorry.
Yeah, sorry. Can I? Yes.
Good.
Okay,
Yes.
I have a question for David Egelman and Albert. So the first one is, I remember that in the experiment, the first experiment of Bacci-Rita on tactile stimulation, I remember that there was a specific role on active movement. So the subject, the participant was better when he could move the camera. So exactly. Then when he passively perceived the tactile stimulation. So my question is, in your device, is there any rule of active movement that can in some way, so which is the role?
Yeah, exactly. Great question. Just in case anyone didn't hear it, it's that with Bacci-Rita's experiment, if you just have the camera pointed at something, people are okay. But if they can move the camera themselves and look at the object that way and then feel it on their back, they're much better at it. So one of the things we find when we use this with deaf participants is that if they vocalize or clap their hands or knock on something, they immediately get it because they're the ones making the sound and they're feeling it. And that closes the perception action loop. So that's the way that people learn very rapidly on this. And with all of the other experiments that we do, we always try to make sure that there's some way that the person can cause something to happen so that they can close that loop. So just as one example with the stock market, if you just listen to the stock market, it would be random noise. So we have to start people off with a game where they can manipulate the stocks on their own, just, you know, and feel what they're doing. And then they can listen to the stock market, that kind of thing. So you're exactly right. You need to close the loop with your actions.
That's also, I think, why our audio bracelet is working, because we have this motor sensor loop. That is very important. Yeah. Thank you. And then I also have another question on for the other speaker. So about the masks, we are using a lot of chirurgical masks in this period with the coronavirus. And my question is about emotion understanding, especially in children. Do you think that in some way facial expressions can, how chirurgical masks can impact? We have an experiment. It has been just accepted yesterday on expression recognition in children with face masks, and it seems that there are some problems. So I was wondering, what about artificial systems?
So this is a great question. I'd love to actually see your paper because, as you can imagine, half of emotion expression community is running experiments with masks, and there is evidence for and against. I think one paper that we are working on is actually using this notion of that facial perception is kind of a pattern completion, that you can, so people smile in their mouth to a smile that is only expressed in the eyes, which will immediately make sense to you. But it's somewhat of a, I think it's a sexy finding in some sense that people don't immediately think that if you just see a smiling eyes that you mimic a smile. But of course, as visual scientists, you know that perception is action completion. So there are these things, and people are actually quite remarkable. And Ursula has a paper of cross-cultural papers with people wearing hijabs and ski masks that also shows that people are quite good exploiting eye cues for reading emotional perception. Having said this, there's also work that the moment you put distance, the moment you make it farther away, the eye crinkle signal is much weaker than a smile signal. you can even, and the computer vision system, you can also, we've actually done this. So we applied that sort, the eye motion system, that, which is this, it's all the same, whether it's Nowe or Affectiva, and and you can see that it degrades much. The signal from the eyes is weaker from the mouth on the smile. So there's other expressions like anger, that it's all in the brow, but smiles are more in the mouth than they are in the eyes. So I think it's a distance and the strength of that signal, and also the kind of smile, because Ekman is not quite right, but there is this phenomenon that the genuine smile are involving the more eye crinkle, and the kind of fake polite smile, or the waiter type of smile. Great to see you, Monica. Right? Are only in the mouth. So it's also going to depend on the type of smile. But send me the paper. That's a great finding. But you are right. The systems are going to collapse on these types of expressions. Mm-hmm.
Thank you.
If I can have still a short question for David. Actually, what do you think about the most exciting new sense, which is leaving your body? And this is what Olaf Blanke is doing, and Erson, and this idea that you can transport yourself into a kind of mannequin or any other objects, like a doll, for example, could be used also in all kinds of games, I believe. And it's something that is shocking for most people, that they can leave their body, right? So have you tried anything like this?
Yeah, I haven't tried these myself, but yes, it's thought that the reason we feel like we're part of this is because our eyes are here, and so we sort of think of ourselves right here. But it's easy enough when people are using, for example, a robot avatar that they're controlling. One of the things we're doing is we built a vest for the robot avatar. So let's say you're doing rescue work where you're sending a robot into a place to, there was some radiation or something. You can send a robot and you can feel whatever the robot is feeling. And the operator essentially becomes in the shoes of the avatar, of the robot. And so,
it's just vision. And if you touch people at the same time as you touch these robots, then they quickly have this feeling that they are there.
Exactly.
So that's something to add.
Yeah, exactly right. Exactly right. So that just demonstrates that our notion of where we are is totally malleable. We can manipulate it easily.
It's a very complex model in our head.
Yeah.
My name is Duch, which means spirit. So I'm delocalized all the time.
Okay. Yeah. I wanted to go back to the conspiracy theories, but we are gradually running out of time. So maybe the last question I really have to ask, and it's about this new global pandemic situation, which for me, or I think that for all of people who have this privilege of remote work, I think that now we are more and more aware how limited are those tools, even if those tools of communication via internet are evolving rapidly now, still they are very, very limited. And in terms of cooperation, I think that not very satisfactory. And the question for, I don't know who wants to take it, but how do you think maybe these sense-enhancing technologies could help us, improve this telepresence feeling of being close to other people, which is, I'm not a psychologist, but I'm a practitioner of group collaboration, and I think it's very, very, very important.
I'm going to say just make one super short comment, because I'm going to leave it to competent people to answer this thing. But I want to make one comment from talking about with kids with spectrum. And this is a paradox of the pandemic, that kids on the spectrum love the education on Zoom, just like they love interacting with robots. I think also the kids on the spectrum suffer the most from the inability to engage in real social interactions, having be pushed on social skills. It's just much easier to do social interactions through Zoom. So you have this dissociation between liking virtual things, liking Zoom, and at the same time, I think being the most challenged or most disadvantaged. And I think the gap is going to be the biggest for those kids. Okay, that's my comment about the pandemic.
Thank you. Someone maybe would like to add something
No.
to this very broad topic.
We need holograms, and we need to touch this idea that David has mentioned, that we can feel somebody's movement. Actually, when I was working in Singapore, there was a fellow who said that, well, people like to have chickens as pets in Asia. And he has created a kind of a rubber chicken that you could have on your desk, and you could feel the movement of the real chicken running somewhere. So this is a kind of really connection to a pet that you can imagine that you may have. So I guess something like that can be developed for humans too. And as you know, the porno industry is very much interested in that. And there are all kinds of vests for people that want to have a sex over the internet. It's a big business that not many people follow. I don't. But I guess I mean there are steps in the direction that you mentioned. Yes.
Okay, thank you very much, and thank all of you. I'd like to thank all of you for this fascinating, and I have this thing too short conversation. And but yeah, we have to finish. So Konrad, please,
Yes, thank you.
Thank you.
So I'm very disappointed because interesting topic has started, but we have to finish. I'm afraid that we just touched this topic of human senses. So this topic has not been exhausted, but of course we had a very interesting, inspiring lectures, discussion, but we have a big decision ahead of us. We have, as I said at the beginning, 5 books. So the question is who will get them? And this question is to David. Do you find, for example, the first five questions sufficiently interesting, or maybe you would like to choose some questions? What do you think about it? Because maybe you can make this choice easier and take this 5 questions from the beginning. What do you think?
Yeah, let's go for the first 5 because they were brave enough to step out and ask.
Yeah, exactly. This is good strategy. They were very brave and very quick, very fast. So for those who answered make questions very quickly, we have 5 books. So please contact us. I can put email to us, and then you will send to us your address, and we will send books. So in my final words, I would like to thank our guests, of course, viewers, and Mirek Filiciak as our moderator. Thank you very much for being with us. The recording from our event will be accessible on YouTube. Stay tuned for our upcoming meetings. Follow us, subscribe us, and of course support us. Have a good evening. But this wishes are to European guests. But for our guests from California, we have to say have a good day, because your day just started. Thank you very much, and as I said, stay tuned. Bye-bye.
Bye.
Thank
you
so much.
Thank you.
Bye.
Thanks so much.
Dziękuję wszystkim. Do widzenia.
No, dziękuję. No,
Dzięki,
cześć,
Piotrze.
Konrad.
Trzymaj się.
Bye.
Musimy się kiedyś skontaktować. Cześć.
Dobra, no, bye.
Thank you very much.
Bye, bye, Monika. Bye, bye.
Thank you. Bye.
Thank you.
Great meeting. Thank you.